Alright, biology students, so today is the Apple Lab Day. So, first of all, you got to start off with your standards and your goals and your learning objectives, which I will put up here magically through the powers of video editing. So today's lab has everything to do about enzymes. We've been learning about enzymes in class and about what they do. They help lower that activation energy of a chemical reaction. Going back to the graph, think about that graph in your head about how it starts off with the reactants. You have the activation energy, comes down, it forms some products. Well, that's what we're going to be doing today. We're going to be manipulating some enzymes. How, you may ask? Well, right here in this apple. Okay? Have you ever bitten into an apple and let it sit for a few minutes and next thing you come back to it and it's brown and mushy? What caused that brown and mushiness in this apple? To be very surprised, it's actually an enzyme inside this apple. Right now, this apple is protected by the outer skin. No air can get into this apple right now. So what we're going to do in this lab today is we're going to cut open this apple and we're going to subject it to a few things. We're going to put it in cold temperatures, boiling water, lemon juice, hand sanitizer due to the COVID situation, and bleach. And so what we're trying to do is we're trying to affect that enzyme, affect that rate of reaction. Remember, rate is how fast it goes. So we're going to try to slow it down, stop it. Heck, we may even speed it up. So we got to see what this enzyme tolerates and does not tolerate. Okay? Does it like a low pH? Does it like a high pH? Does it like to be warm? Does it like to be cold? Or none of those at all? So that's the whole point of the lab today, is manipulating the enzyme to affect its performance, just like you and I. Now, I don't like to go outside and work in the cold. It's not my thing to do. I much rather work in the heat. So you're going to get more work out of me in the hot summer than you are in the cold winter. Now, that's different for everybody. But let's see what this apple does. Have you ever got the apple slices at McDonald's before? And they're already sliced up, but one thing that's unique about them is, why are they not brown? We just learned that if air comes in contact with the inside of an apple, it starts the reaction. So how is an apple slices from McDonald's not brown? What are they doing? Maybe they're putting something on it. Maybe they're putting something inside that sealable bag. I don't know. But what they're doing is they're trying to maximize profit. Okay? It's easier to sell an apple that looks nice and ripe than it is to sell an apple that's brown and mushy. Okay? So McDonald's has something figured out. Maybe we can try to figure out what they're doing with their apples so they can stay preserved and go to you, the consumer. Alright, just your ordinary apple. We actually picked this one this past weekend at the apple farm. Like I said before, right now the skin of this apple is protecting it from the air. Now, thinking about reactants and products in a chemical reaction, okay? Now we're just going to do simple reactants and simple product. This apple has an enzyme in it, polyphenol oxidase. Notice how I said oxidase, ASE. Remember, ASE at the end of a word means an enzyme, okay? So that enzyme that is in here reacts when it comes in the presence of oxygen. So oxygen is going to be one of our reactants that's going to go into this chemical reaction. The product that we're going to get out of this is a very large organic compound that I'm not going to bore you with. So just know that it's going to form an organic compound and look brown. That's how you know the enzyme is working. Alright, so what are we going to do to affect this enzyme? Well, first thing is you got to have nothing at all. This is like your control group, okay? None of the variables are going to be affecting the apple. It's going to be naturally just doing its thing, okay? So nothing. We're going to put this apple slice in the freezer, obviously subjecting it to temperatures under, 32 degrees Fahrenheit. We're going to drop an apple slice in some boiling water, and we're going to see how, boiling water 212 degrees can affect this enzyme? Will it speed it up, slow it down, or nothing at all? Lemon juice. If you look this one up, this one is a low pH. So it's an acid, has around about a 2 pH. Bleach. Bleach, this one's actually a base, or sometimes they call it a caustic. I'm not sure the exact pH on it, but it's somewhere around 10 to 12, okay? So maybe it likes a high pH, or maybe it doesn't like it at all. We'll find out. And lastly, since everything in our life is dealing with hand sanitizer these days, let's see if hand sanitizer has to do anything with it. The main ingredient in hand sanitizer is alcohol. We'll see if alcohol can affect this rate of this enzyme and the rate of the reaction. Our whole goal is to slow down this reaction. We want to not turn this apple brown. All right, so let's take a look at all of our results here. And what you have to do is you have to really compare it to the control, because these were all the variables that we introduced into the experiment. So let's look at our control there. I'll even bring it up to you so you can see it up close. This has been roughly, I think, about a half an hour of, so you can see there definitely some browning going on. You definitely see that enzyme going to work. All right, so let's compare that to the first one here. Let's go to the lemon juice. Remember, this is not a low pH. All right, if you look here side by side, let's first just look at the lemon juice one there. So right now you should be drawing a conclusion about what this enzyme does in a low pH. Does it slow down the reaction, speed it up, or no change at all? Okay, that was the lemon juice. Let's look at hand sanitizer. Now, hand sanitizer is alcohol based. That's the main component of that. Now let's look at this one here. Now you can see here, as I fix my camera, there is some brown for sure. I keep dropping this thing. Compared to the control. All right, so you can see that there was a change. All right, so let's go to bleach. Bleach has a high pH, I think around 10-12 area. Once again, you can look here. Look at that, look at that. Compare it to the control. All right. Now let's go to temperature. Which temperature do you think? All right. Let's go with the control. There's at room temp. Then this apple that was put in boiling water. Look at that. So you can see there. All right. And then lastly, we'll do the freezer one. You can see there, definitely some browning there. Definitely some, obviously definitely some browning in the control, but you can definitely see the result. So right there, you should be able to draw a conclusion looking at these again. Let me turn them to the side. Maybe this, sometimes different angles can help see things. All Let me get my camera here, adjust it for you. Alright, right there, let's look at the control again. Look at that. Compared to the lemon juice. Hand sanitizer. Bleach. Control again. Boiling water. And freezer. Definitely a conclusion that you can draw about this enzyme and what was going down. Alright guys, hope you learned something, and I will see you next time.